I like grid view. Okay. Okay. Do you copy? Entonces the procedure for solving this kind of equation is always the same. You have 2 logarithms, 3 logarithms, 4 logarithms, I don't care. You condensing any logarithm using the property number, in this case 5, because it's plus. Apply property 5 and allow me condensing these 2 logarithms separately and only one as a single. And this is multiplication, this expression, time this expression. You write like that, x parenthesis x minus 24, and everything belongs to the argument of the logarithm, equal 4. Do you follow me?
Yes.
Now, after that, you put an arrow. Okay, this arrow means that you convert it to exponential. Because I suppose that when you change to exponential, you see much better the algebra. Okay, just remember the exponential. I immediately ask by myself, what's the base? What's the base? The base is 3. And you put the big 3. The exponent always is the answer for the logarithm of 4. Is equal x minus 24. Actually, when you check to exponential, it's not exponential because the exponent is a constant, and you raise 3 to the 4th power is 81. 81 is equal x minus 24. So now I believe this is a quadratic equation because when you apply distributive property here, it's something like that. Of course, I like so much express this equation standard. Entonces es x squared maybe minus 24x minus 81 equal to 0. Ready to start. So we convert the complicated problem, que es logarithmic equation. We finish and finally in one quadratic equation. And you solve this quadratic equation in the way that you know very well, using the quadratic formula or factorization. Factorization is a little bit complicated to find. 81, 24. I know the answer. However, it's not obvious, right? I know. So you apply quadratic formula A, B, C. A1, B is A1, sorry. B is negative 24 and C is negative 81. So now my formula is minus B plus or minus square root B squared minus 4AC divided by 2A is 24. Double negative of the formula, negative of the value together become positive, plus or minus square root negative 24 squared minus 4 multiplication by 1 get nothing, multiplication by negative 81 divided by 2 times 1. Okay, so I put in my calculator. Remember, we focus here on the expression inside the radical as always, and you put 24 squared. Actually, you know, when there's negative, become positive, no? So in my calculator, I omit the negative. I put 24 squared. It's 576. Plus, be careful with the sign because we have double negative. 81 times 4 is 324. And 324 plus 576 together is 900. Wow, amazing. I like that. And the square root 900 is 30. Is 30. Okay, so far we have this result. We have 24 plus or minus 30 divided by 2. So I separate into pieces as always, positive and negative. positive and negative. Okay, is 24 plus 30 divided by 2, and 24 minus 30 divided by 2. Okay, 24 plus 30 is 54, and 54 divided by 2 is 27. And this is my potential. Be careful with this. This is typical equation. Okay, you need to verify the solution, because during the transformation you change the algebra, and maybe this value don't belong to the domain of the logarithm, because remember, logarithm only accept positive number, negative number no, to be undefined. This is negative 6 divided by 2 is negative 3. Just at the beginning I expect this value, because you, for example, you are doing the problems by factorization. Suppose that you believe, or you try, or you dare do the factorization. The combination is 27 and 3, because 27 times 3 is 81, and 27 minus 3 is 24. And the sign R, maybe this negative and this positive, and you get the same result. Okay, x equal 27, but this is hard to see. I know, I understand. Are we finished? No. This is the most important moment, the checking part. Let me try to do my best. 27. I am expect negative 3 doesn't work. It's obvious it doesn't work, because okay, negative 3 doesn't work. The reason is negative, no? And logarithm of negative number to be undefined. Suppose that you try to do logarithm of base 3 of negative 3, so I plug it in the original, this one. Okay, yeah, immediately you see that, wow, no, doesn't work. No. So negative 3, no solution. No solution of the original logarithmic equation. Of course, a solution for the partial intermediate quadratic equation. Pero es que the problem is que during the transformation, you change the equation. Okay, 27. Let me try 27. Logarithm of base 3 of 27 plus logarithm of base 3. This is a checking for the 27, no? Of 27 minus 24 should be 4. I claim this. Entonces el logaritmo base 3 of 27 plus 27 minus 24 is 3. Logaritmo base 3 of 3 should be 4. Well, I remember property number 2. Okay, property number 2 say that when you have logarithm of the any base and the number inside the argument is the same as 1. So this is a particular example, because it's 3, the base is 1. This is 1. Blow this guy, let me see. What the exponent? Suppose that you try to do, remember, by hand or calculator. Either way. By hand is, you, to see more clear, you convert this statement that you don't have idea what value of this. Well, it's obvious. Well, okay. You convert to exponential. When you convert to exponential, the base is obvious 3. The base is obvious 3. This 3. And the exponent is the thing that I try to find. Equal 27, but I know that 27 is 3 to the third power. Therefore, we have two exponential, the same base. The conclusion is the exponent is 3. Another possibility, well, no, let me finish. 3 plus 1 is 4, no? Oh, okay. The answer 27 is good. Another student that don't like that way, no problem. You can use a calculator. In the calculator, you apply the standard logarithmic, maybe natural or maybe common. Suppose you don't like natural, you put log of 27 divided by log, and this log is the log of the calculator key. Log of what? Log of 3. And the answer is 3. Unbelievable. Unbelievable or no? It's illogical. Because 3 to the third power is 27. Remember the idea behind the logarithm? You need to find the exponent. You need to find the exponent. When you raise the base gets given in the beginning, gets 3, it should be 27. That's the answer. Any question? Do you understand very well this or no?
Yes.
See, I summarize the algorithm is you have several logarithms, you condense in only one. After you convert the logarithm statement to exponential, and magically happen that you obtain maybe quadratic equation or maybe linear equation. So you delete everything, no logarithm anymore, no exponential anymore. And so now you're solving that. But it's important, three important, checking. Plugging in the potential solution into the original to verify that. Okay? Let's do another example. Okay, example 2. Example 2. Well, in this case, logarithm of base 2. Normally you see in these problems, not exactly standard. Logarithm you see non-standard. Oh, no, I don't know. Either way, arbitrary. X minus 5 equal 4 again. Which? Okay, what should I do? What should I do? What should I do? What should I do? Step number 1. You have 2, 3, 4, 5 logarithm, you condense it, right? In this case, I apply the property 6, not 5, because it's minus. So you condense this in only one logarithm is division. I put the positive in the numerator and the negative in the denominator. And this now is the new argument of the logarithm. Okay, now ready conversion to exponential. The base is 2, this small 2, I copy like a big 2, the exponent of 4, get the answer of the logarithm, is equal to 3x minus 2 over x minus 5. And 2 to the 4th power is so big as 16. 2 times 2 times 2 times 2, 4 times is 16. In this moment we have linear equation. Well, no, okay, it's a rational equation, but it's okay. You apply cross multiplication because it look like proportion. So you apply cross multiplication, you multiply 16 times x minus 5. What is my goal? My goal is eliminate the fraction. And 3x minus 2 times 1. Boom. Linear equation. Now multiplication. 16x minus 80, I guess so, no? 16 times 5 equal 3x, sorry, minus 2. So for x, 16 minus 3x is equal 80 minus 2. This is 13. This is 78. Divided by 13 both sides. The answer is 6. Oh, cool. Only one solution and positive. Maybe this solution works, but I need to verify. How you verify? I recommend you split the paper into parts, and this is the checking part. Check for x equals 6. Plugging it in the original. Mandatory this. You don't check it, 0 for you. Okay? Logarithm base 2 of 3 times 6. It's a period indicate multiplication. Minus 2. Minus logarithm base 2 of 6 minus 5. Should be. I claim that because I'm not sure if it's true. See, I prove it's not true. If we have only one potential solution and 6 doesn't work, That means that the logarithmic equation have no solution. This, but in this case, yes. Okay, it's multiplication. This is 18. According to the order of operation, you should do this. This is 18. No? 18 minus 2 is 16. The basic logarithm of base 2 of 16 minus logarithm of base 2 of 6 minus 5 is 1 equal 4. You have to remember the property number 1. Property number 1 say logarithm of the any base of 1 is always 0. When you see 1 inside, the argument of the logarithm of this part is 0. The basic, I need to prove que logarithm of base 2 of 16 is equal to 4. It's obvious, yes, no? Because 4 is the exponent necessary to raise 2 in order to get 16. However, suppose that you don't know or don't see clear, you convert to exponential. The base is obvious que es 2. The exponent is 4. Is equal to 16, que obviously is true, super true. Now the solution 6 is perfect. Boom. Any question? No? Okay. Everything's clear, right? Remember, after that, yeah, after that, we apply everything we know, exponential, logarithmic, and the word problems. Okay. And the problem of the finance, problem of the physics, chemistry, biology, que somehow involve formulas que contain exponential and logarithmic. Okay, now let's move on to example 3, que bring me new situation. Example 3 is different. It's logarithm of base 14. 14 is the base, of course, non-standard, of x plus 5 is equal to 1 minus logarithm of base 14 of x. Well, the professor explained me that the first step in the solution of the logarithmic equation is condensing. In this case, I can know condensing because this logarithm is located in the opposite side of the equation. But okay, the first thing you should do, put in the same side. For example, this stay here, but another no. Another I move to the left, like that. Okay. Now, ready to apply property 5. Okay, the property allow me condensing this logarithm in only one. And this is the multiplication x times x plus 5. And this is the new argument of the logarithm equal 1. Now I change to exponential. Okay, the base is 14. The exponent is 1. By the way, it's invisible. 14, 14. That's it. Equal x times x plus 5. I believe okay, this is quadratic equation because you apply distributive here. It's x squared plus 5x. Okay, let me write in standard. In standard 4x squared plus 5x minus 14 equals 0. Ready for solving the quadratic equation. Okay, now I open two parentheses because by factorization is pretty easy, no? It's 7 and 2, no? 7 times 2, 14, and 7 minus 2 is 5. What sign? Positive 7 and negative 2. Therefore, x plus 7 equals 0. Indicate us que es negative 7. And negative 7, I suppose, que doesn't work. Well, not always the negative doesn't work. You need to plug it in the original, but it's obvious because negative 7 plus 5 is negative 2. No good. Entonces, x minus 2 equals 0 is positive 2. I need to verify positive 2. Negative 7, I know very well it doesn't work. Because that depends, no? Suppose que this number is not 5, it's 10. When you plug in negative 7, and then it's positive, so it may be work. But no, it's not our case now. Okay, now, checking for 2. I need to prove somehow the logarithm base 14. Okay, I plug in. I prefer using this. It's not exactly the original, but it's the same. It's equivalent, 100%. The transformation, the thing that change is when you change to exponential. Okay, yeah, it's not 100% equivalent. Not always, you know, in some cases. So this is 2 plus 5, because I replace x for 2, plus logarithm base 14 of 2 should be 1. And 2 plus 5 is 7. Plus logarithm base 14 of 2. Oh, nice. And together, when you apply one more time the property phi, you put together logarithm base 14 of the multiplication. Multiplication 7 times 2 gets 14. Wow, nice, because they are coincidence. You apply the property number 2, que say que logarithm of the any base when the argument is coincident 100% with the base is 1. Therefore, okay, cool, this is okay. Apply the property number 2. Okay, nice. Let's try one more. One more example. Do you follow me? Everything okay?
Yes.
Yes.
Okay. Look, one more example.
Yes, Professor.
Yeah. After that, we see more example in the review. Okay. This is example 3, no? Example 3 is log 3 plus x minus log x minus 3 equal log of 3. Wow, what the hell? I see something weird in this example. First, no specification of the base. When there's no specification of the base, is missing number here. What do you suppose can happen? And the notation that we are using in algebra, when there's no specification of the base, it's because. Who help me to understand this? It's because I forgot. No, I don't. So this is important, the interpretation. This, when the base is missing, is because the base is 10. Remember, there are two special cases. The common, que es base 10, and the natural, que es the base E, but in the natural, the notation is different, it's LM. Y in the common is LOG without specification of the base. So I suppose if the problem is given like that, actually in the test, you can face something similar. And you need to interpretation. No base. Entonces 10 is common. It's exactly the same, the logarithmic we have in our calculator. Okay, but okay, I understand that part. No problema. Clear. The next thing we are can see is that normally in the example that we are doing before, we have 2 logarithms. Now we have 3 logarithms. And the 2 on the left hand side and 1 on the right hand side. So you move everything to the one side? No. And the reason is because you apply the property 6 now. You condense these 2 logarithms in only one. So logarithm base 10 of the division 3 plus x minus 3. This is the new argument of the logarithm on the left. And on the right, we have logarithm base 3. But I know very well the logarithm is a one-to-one function. Therefore, when you have 2 logarithms, exactly the same we are doing with the exponential. If We have two logarithms, and the base is the same. We can omit the logarithm because the logarithm is one-to-one function and the argument is the same. And you reduce magically, very, very similar to the solution that we are doing in the exponential, that we can express it both sides using common base. Well, it's the same, but it's not exponential logarithmic, but it's the same base. So it's one-to-one, therefore you reduce the problem in one linear equation. You apply cross multiplication, you apply 3 plus x times 1. Get the number here because the 3 is a whole number. Yeah, I don't get any whole number. The denominator is 1. I multiply 3 times x minus 3. Okay, now the rest is pretty easy. The rest is just distribute and solve for x. You apply distribute 3x minus 9 because 3 times 3 is 9. Let me try to do my best. My best is, well, maybe 3x stay here on the right hand side, minus x, okay, move to the right hand side, 3 stay here, plus 9. Oh, this is 12, and this is 6. 6, not 2. Divided by 2 is 6. X equals 6. Okay, and that's it. No, I need to check it. Check it where? In the original, maybe? Yeah. I need to verify que el logaritmo of 3 plus 6 minus logarithm of 6 minus 3 should be equal logarithm of 3. Minus 3 plus 6 is 9. Minus logarithm of 6 minus 3 is 3. One more time, if you want, you condensing this and this together using the property 6. Property 6. And so you put together logarithm base 9 over 3 division should be logarithm of 3. It's obviously true, no? Because in this moment, when you have only two logarithms, you can delete mentally the logarithm of 9 over 3 is equal to 3. So obviously 3 equal 3. Okay, true. And the solution is perfect. Clear?
Yes.
Yes.
Okay.
Professor,
Go ahead.
I have a question. How did you get like 3/1 like in the first one of the first steps?
Yeah. You say here?
Yeah.
You have one equation like that. 3 plus x minus 3 equal 3. This one do not exist. But I understand that if the 3 is a whole number, 3, and then any whole number expressed like a fraction, a denominator 1, because it's invisible, right? Divided by 1 is nothing. So it was comfortable for me to understand the cross multiply. Maybe make sense now?
Yeah. Yes.
Clear?
Yeah. Thank you.
Okay, let's do an application. I want to explain the formulas. You don't need to memorize, of course, the formulas. You have in your notebook, no? And so now you need to understand the word problem and also apply the formulas, no? The first formulas you need to know is the formula about compound interest. It's a finance. Compound interest. This is easy. The idea is classical. You have money and you deposit your money in your bank account. Okay, let me call P. P is the present value. So it's the money that we have now. Money now. Present value. And you deposit present value, and you deposit this money in the bank account, and the bank account have interest rate. Because my money, see, you don't withdraw the money, my money increasing, no? Let me call R, little r represent the interest. rate. Okay, so my money increasing like that. The formula is future value. Suppose que you never withdraw the money in 10 years, or no sé, I don't know. 5 years, 2 years, the problem is specification, the amount of time, T is time. I need to find the future. This is the future value. And I need to understand the money I have after 10 years. No, this is the idea. So the idea and the formula involve P, capital P, present value. It's the money I have now. I need to find how much money I have in 10 years. See, I never touch this money in bank account with the interest rate is 2%, 3%, 3.5. Okay, it's the interest rate. Okay, and okay, so the formula, there are two different formulas, because I suppose the most popular is this: future value is equal present value, parenthesis 1 plus r over n raised to the nt. Let me close the box because it's important. Okay, let me try to explain this. Who is M, who is T, who is R, who is P? Well, P is present value. R is interest rate. Okay, it's fixed by the bank. Now time is the time the money stay in the account. But N is a compounding. What means that? There are different compounding depending, for example, see my account change annually, N is 1. 1 is annually. See, N is 2 is semi-annually. I want to explain the interpretation there. And so on. N is 4 is quarterly. And the problem is specification, no? Because when you negotiate your account, you need to know the periodicity of the compounding of this. We have 12 monthly and so on, no? It's the amount of month okay, we have in 1 years. Monthly H L Y. Monthly, weekly 52, because we have 52 weeks in 1 year. Or daily, que is 365. You assume this, no holiday. Daily. Okay, and so on. And now, don't worry too much for this, because the problem is specification. And what is the interpretation? The interpretation is, look, I have money. Let me see one picture to understand this. I have present value P. It's a money, and it's a time. How change my money and the time? Well, depending the periodicity. So, for example, you have you have 1 year. This is 0 now, and this is 1 year. And suppose that my account is quarterly. That's mean that my money increasing 4 times in 1 year. First quarterly, second quarterly, third quarterly, fourth quarterly. And my money increasing like that. Boom. Boom. And always the step is bigger. This is the magic of the compound interest. So my money increasing, depending of the compounding, no? This is discrete. However, we have another possibility when you don't know very well the compounding you assume. For example, low in bank account. And another thing is like a investment using maybe a stock market or bonds. The formula is different. The formula is future value is equal present value, but it's e to the RT. Oh, it's because you assume this is continuous. It's continuous because you suppose that the money increasing like that, like exponential, right? You suppose that m is infinity. Entonces you say, well, this is logical. Yes, it's because, for example, in the stock market, the thing changed too fast. 5 minutes. Entonces you suppose que es no like 3 months, no, it's too fast. We're using that formula. Okay? Okay, let's apply these formulas in the word problem that I bring now. Okay, and you help me and everyone be ready to using your own calculator. Okay. Any question? Well, let's see the problem a little by little, you understand that. Okay, let's suppose this first problem. Okay, there you go. Boom, wow. What the hell? Look at that. Let me read that. Okay. Okay, it's a typical problem of the compound interest. If 10,000 is invested in account 3% APR, compound quarterly, how much money will be in the account in 5 years if no money is withdrawn? Okay, now, in your opinion, what is 10,000? 10,000, what is that? Future value, present value? P, Emily P. Emily said P is 10,000. It's the money I have now. Who is R? Who is R? Who is R? Who is R? It's 0.03. Very well. Okay, and the formula, okay, normally in the common language, you express the APR as a interest rate and percentage. However, in the formula, never. We express a percentage. You divide by 100 and you obtain decimal the interest rate. Cool. Entonces, what about T? Who is T? Who is T? Who is T? Who is T? Well, N is 4. Yes, you are right. Compounding is 4, but this important keyword.
5 years.
5 years. And always in the formula, you express the time in years. Suppose that you need to find another dimension, another unit of the time, a month, so you need to convert to years. So the formula is created thinking que es in years. Okay. Now, entonces, what is my unknown that I don't know? Future value, right? So apply the formula. The formula is future value is equal present value 1 plus R over M raised to the nt. Be careful. Future value is equal 10,000 parentheses 1 plus is 0.03 over 4 and raised to the combination nt. N is 4, look at that, and time is 5, and together multiplication is 20, so the exponent is 20. Okay, now calculator, everyone working. You put in the calculator, be careful, but you put in the calculator. This is the display of the calculator. You put 10,000. Multiplication, open parenthesis, 1 plus 0.03 divided by 4, close the parenthesis, power 20. Boom. What's the answer? Exactly, 11,611 cents. It's important, 81 or 84? 84, okay. No, it's okay. This is just 1 cent, 3 cents. 611 0.84. It's important in the calculator, okay, don't know exactly what is the nature of the our problem. Give me more decimal place, but no. You truncate or round off to the 4 decimal place because we are talking about money and have no money to say fraction of the same. Okay, so now this is dollar, and you truncate or round off 2 decimal place because it's currency, it's money, right? Makes sense, right? Okay, nice. I understand the first problem was easy for me. I believe okay, everyone understand. Yes or no?
Yes.
Let's move on to the more complicated. Suppose this one. What the hell? My device. Okay, this is the second world problem. Look at this, is interesting a little bit. It's a car. Okay, John want to buy a new car. Suppose the price is $30,000. He has only, he saved, okay, 27,000. Find the number of years it will take him from his 27,000 to grow to 30,000 at 4% APR compounding quality. Okay, I suppose que John deposited $27 in the bank account. I need to find the time que si I never withdraw the money with the account, he will get in the future 30,000. Okay. So let me try to understand my problem with the formula. The formula I know is future value is equal present value 1 plus R over M and T. Okay, this is my formula, but I need to identify who is P, who is A, who is R, what are the things I need to find. I have no idea. Okay, who is P? Who is P? 27, very well. It's the morning I have now. Who is A? Okay, 27. 27 es P, I agree. A, que es the future, es the money que yo need, es 30. Ajá. 30,000. Okay, what more information we have in this problem? Oh, compounding quarterly. R is equal to 0.04 is the interest rate, the present decimal, and N is 4, no? Cool. And what is my, oh no, what is the thing I need to find? N is 4, yeah. You are right, because N is 4 because of quarterly. I need to find what? Who I need to find? How long? No, how long? I need to find time. I have no idea. Okay. With this information, I move into the formula. Yeah, I've tried to do my best. Is 30,000 is equal 27,000 time. 1 plus 0.04 divided by 4 raised to the n is 4 until I have no idea. Do you follow me so far?
Yes.
So what kind of equation we have in this moment? We have exponential equation because my unknown ST is located in the exponent. So I need to do something in order to, in the final answer, you put t equals something, no? Okay, this is a classic exponential that we found, or we need to say you set up according to the problem, no? Okay. So what should I do? I am lost. Well, maybe you divide both sides by 27. Now this is algebra, guys. You divide both sides by 27. Because my goal, remember, is T, no? I need to manipulate this equation in order to isolate the thing. Oh, easy. At least 3 zeros cancel. And here we can reduce the lowest term. This is 30 divided by 27 divided by 3 is 10. Divided by 3 is 9. No? It's 10 over 9. I reduce it. It doesn't matter. Or you put directly here. And the right hand side, bueno, it's easy. You have 0.04 divided by 4 is 0.01. At least that part is 0.01. Plus 1 is 1.01 raised to the 40. Do you follow me, guys?
Yeah.
Okay. This is a classical example. We cannot put equal base. So put each other the same base. It's impossible. Definitely, you need to apply logarithm. What kind? The standard. The standard que using our calculator. Entonces, maybe log, you apply log both sides. Log, como 10 over 9 is equal log, or naturally, either way, the answer doesn't change with the base, with the standard that we're using. Entonces, in that moment, I apply the property number 7. And the property number 7 is magic, because this exponent go to the front as a factor. So we have logarithm base 10 over 9 is equal 40 times logarithm of 1.01. And my goal, remember, is solve for t. Therefore, for solve for t, I propose you this logarithm of 10 over 9 divided by both sides by 4 times logarithm of 1.01. This is t. Of course, t is in years. Entonces now you know, you need to have some estimate idea how many years. Bueno, depende. You round to the round, pero round no down, round up, because it's optimistic, no pessimistic, no? Entonces now put in the calculator, please. Put in the calculator. Logarithm 10 over 9. Be careful, be careful. This is the display of the hour calculator. How you type in that? You put an log. You press log key. You put 10 over 9. Close the parenthesis to see I finish this logarithm. Division. One parenthesis. Important, this parenthesis, because we have 2 guys in the denominator. We put 4 times log of 1.01. Close the parenthesis of the logarithm and close the parenthesis involved in enclose everything in the denominator. Okay, guys, I wait for you for the answer. How many years? Exactly. 2. Emily say que es 2.647, something, ¿no? Years. Entonces, what is the idea for the, what is the advice for John? Bueno, John, you need to wait. Entonces, si you say this, John don't understand very well. Entonces, o es 2 years o es 3 years. It's 3 years. It's 3 years. So now, of course, in 3 years, we have a little bit more money. And maybe this money, John spend for the insure, maybe, I don't know. Do you follow me?
Yes.
Okay. Okay, now let's move on to the next problem. Every problem of this is about money. Problem number 3, no? Yeah. Okay, there you go. Let me try to move. Zoom. Here. Different problem. This is a little bit more weird, no? This is about investment using find the future value that result from the invested and present value of $2,000 at 8% APR, compounding continuously from 1 year and 10 years. So we have two conditions. This is classical. And in that part, okay, you have two problems in one problem, no? And you need to find two answers. No? One answer is in 1 year, and another answer is in 10 years. No? But this word continuously, because we are talking about invest, pero I don't know si es en stock market. Find the future value for the result from invest and present value. Okay. Es obvio que present value is given, que es P. Es obvio also que interest rate is 0.08 APR. Continuously, and continue change the formula. We don't use it anymore and continue the formula capital A equal P 1 plus R over M and T. No, this formula is using when the money increasing like stairs, down. Now the money increasing continue, and the formula is different. The formula is A is equal P, E, que es the mathematical constant exponential, pero the base is E, RT. Okay, entonces we have two problems, future value in 1 year, and future value in 10 years. It's obvious in 10 years it's more money, no? 1 year, no plural, only one. Entonces 2,000 exponential E, que you need to know how you find in your own calculator, E to the interest rate, que es 0.08 times 1, okay, 1 is nothing. If you want, you omit that part because multiplication by 1 is nothing, or 0.08 times 10. Boom. So you need to be familiar with the exponential E. Exponential E, guys, you can find in any calculator in the same key. For example, in the calculator I have in my hand right now, I have the key LOG and the key LM. And the key, and the same key, press second. Okay, my calculator is blue color. So we have another key that is second. You apply the second function of this key. You have 10 to the x, que es the exponential associated with this, the same base, and e to the x. So I need that. To press this in our display, you press, of course, 2,000. Multiplication. E, but you press E, how? Let me show you how. Or let me try how in my calculator. No? You try in your own calculator. You put 2,000, multiplication, after second ln key, que es exponential. Entonces I see something like that. Power parenthesis. Y inside the parenthesis, I put 0.08. Close the parenthesis and press enter and end the story, at least the first part. Boom. Who helped me? In the second? Come on, everyone working with the calculator. I need answer. 1 year, 10 years. A ver. Yeah. Emily say que yeah. Es en 10 years, Emily, ¿no? Emily say que es $4,451 and 8 cents, ¿no? 8 cents, Emily. I understand well. Yes. Okay, okay. And what about 1 years? I suppose que es smaller, more, no? Is show me. I don't see anything. Oh, it's 2011 and 57. Yeah. 2,166 and 57 cents. Is the answer. Guys, you have to practice with your own calculator, no? Okay? You have a question or no? You get same answer like Emily and me?
Yes. Yes.
Yes.
Okay, this is typical. Well, I need to explain everything because in the Alex, you see more complicated problems. Any situation that you don't understand, make a screenshot and send me. I try to help you, right? Suppose now this one. This is more complicated because one investor buy bonds. Entonces the bonds have a maturity time and redeem it, for example, in 10 years. Okay, 10 years. The time is given 10 years. How much should be willing to pay it now if you want to return of 7%? So basically it's the problem of the comparison. So we have two situations. We have one situation, okay, I call situation number one, and the situation number one is offer 7% compoundly monthly. Monthly is n equal 12. And second situation is a smaller interest rate is 6% compounding continuously. Continuously is infinity, but infinity, the only thing you should do is change the formula. So we compute in the condition one using n equal 12, using t equal 10 years, but I have no idea what is the present value and the future value, no? Well, actually, the present value is the thing I need to know, because the question say, how much should be willing to pay now? So the only thing you don't know is the present value, no? So you need to compute both situations. It's two problems and one problem, and finally we compare condition one and condition two, and you try to find the optimum, so the best. What is the best? Well, I suppose that the best is the cheaper, right? No expensive. Okay. Okay, so we have two formulas. Let me try to manipulate the formulas. The formula is the classical formula, que es a future value is equal present value 1 plus r over m raised to the nt. It's a discrete problem, que the money increasing like a stair, taca, 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 and another que continuous, que is this. The money increasing different is future value is equal present value e to the rt. It's continuous. So solving the first problem, bueno, pero I don't know what is the future value. I don't know what is the future value. But you assume hypothetically one quantity. It's the same, and to help me to compare. Suppose 1,000. Hypothetically. Totally irrelevant. because you suppose another 2,100 is the comparison. So you need to, it's totally irrelevant, the quantity. So you obtain always the cheaper option. Okay, so now to solve for present value, because my unknown is equal future value divided by 1 plus R over N NT. So it's the same formula, right? It's the same formula. But the only thing I did was isolate P. Okay, I moved this part divided here. Okay, now substitution. P is equal 1,000 divided by 1 plus, well, it's 7, it's 0.07 divided by 12, because it's monthly, right? And raised to the multiplication, N gets 12 and T gets 10. And together is 120. It's the exponential I have. Okay, ready to calculate now. At least the first part. Come on. Not only Emily, another participation, guys. Put in your calculator and you let me know. Suppose you are doing bad, no problem. The answer is Emily again. The answer is 497.60. No, it's 60 cents because you. Okay, this is the price. 60. Yes, 60. Another auction. This is the first one. The second is using that formula because it's continuous, no? And present value is equal future value divided by e to the RT. Present value is equal, well, I assume the same, no? Hello. I assume different, I cannot compare. Exponential que es e to the 0.07, 0.07, 0.07, no, 0.06. It's 6, not 7. 7 is the first condition. Interest rate a little bit, multiplication by 10. Okay, so in the display of the calculator, you put it like something like that. You put 1,000 division exponential e to the exponential. So inside you put 0.06 times 10 and close the parenthesis. In this case, not necessary put. If you put the parenthesis outside, it's okay, but not necessary. And the price, the condition 1, and the price, the condition 2. This is the organization I want to see in the test guide. And we compare for the best option, for the optimum. Is, is 548 and 81.
Professor,
I
have a question. In the continuous formula, what does the E stand for?
E is the exponential, que es the same key. Okay, and your calculator, miss, you have two keys, LOG and LN. Yes or no? However, we have another key in your calculator that is second function. Yes or no? Or shift?
Oh, yeah.
Entonces you see here e to the x. Do you see or no?
Yeah.
How you select that function? How you select that function? You press this key first, and you press this key and down is selection this function. And immediately you see E, power parentheses, and you type in inside the parentheses 0.06 times 10.
Oh, got it.
Try. And let me know so you get the same answer. Hold on.
Give me a second. Let me write it.
Yeah. Go ahead. Professor, just to
I
clarify.
did.
Bueno, okay. No information. Yes, thank you. No information. The problem, no information about the future value. Entonces, I assume complete arbitrary value because actually the only thing I need to do is comparison in two conditions, condition 1 and condition 2. Entonces, I assume arbitrary. Suppose que you assume different like me. You assume 5,000 or $50. So now we get different answer, but it's possible compares. Because in your opinion, what is the best option? The option 1 or the option 2? What is the best option? The option 1 or the option 2? Remember, we compute price, present value. It's the money I need to pay now. Entonces, it's good to pay back, to pay more or to pay less.
Less.
No, entonces option 1 es obvio que es the best. This no. Any other question? Cool. It's easy. Okay. Let's move on to another kind of problem. So we can see in the test, only one, Ian Alex, another kind of problem. Okay, forget about money now. No money anymore. It's about, population. For example, this population. Okay, population, remember guys, playing of the small animals or microorganisms, bacteria, virus, maybe propagate exponential, no? And so this problem talking about insect population growth according to the law of unlimited growth. Initial amount of insect was 500 and grow up 611 in 10 years. How many insects I have in a month? Let me try to understand this. The formula is different. It's similar, no? But it's a little bit different. Population to any time is equal P null, que P null is the initial population, E to the KT. They call in that part biology, physics, no call R. R is finance, interest rate. This is similar, but it's not R, it's K. And K is a constant because actually I know that this is exponential, no? Exponential look like that. But we have a family passing through the same point, depending the K, no? Si K is 1, si K is 2, or si K is 3, or si K is fraction. 0.1. Like we have family of the K. Somehow give me information about how fast increasing the exponential, no? However, let me try to understand because I am totally lost. For example, this is a population that represents the amount of insect at any time. At t equals 0, the problem says we have 500 initial. Initial means 0, and it's a time. It's this time. We have 500. Suppose 500. And this is increasing exponential. Woo, like that. The negative part is not important. It's only important the positive part and this word problem. However, this is condition, let me call condition 0. C0 is this. It's logical because it's at t equals 0. However, the problem says at t equal 10 days, so this axis, que is the axis of the time, depending on the problem, is measured in minutes, and day, and years, but in this case, days. Month. Okay, this is the problem says that 10 years, the amount of this inset is 611. So this is condition 1. Let me call condition 1. And condition 1 is the 611. 611. This is 611 inset. Entonces, my unknown, how many insets, the quantity of the inset in a month. A month is equivalent 30 days. What is the reason I change the unit? Because to be compatible, see, this is day, this is also day, no? It's crazy. Working one a month, one a day, no. And 30 days, okay, I suppose okay, this is 20, this is 30 days. I need to find, how many inset? How many inset? I believe I put too fast here. This is my quantity I need to find. How many inset in 30 years? So basically it's P evaluated 30, no? Okay, but we have some problem, and this is condition 2. So this problem normally have 3 conditions. Condition 0 is the initial. Condition 1, okay, always we are using to find the K value. So the condition 1, we are using to find the K. Always. And the condition 2, no. Condition 2 is the final answer. K is this. Okay. It's a little bit complicated at the beginning, but no, it's no big deal. So let me set out the formula, specific formula for the condition 0. Oh, condition 0 is 500. 500 e to the kt. So using the condition 0, allow me P null. P null is the initial. Now I'm going to find the K, que is the, the rate of change. How fast increasing the exponential in this specific problem. We evaluate everything in the condition 1. But the condition 1, everything is given. Well, not everything, no. Almost everything. P is 611, que is the amount of inset that we have in 10 years. So P in 10 is 611. 500 exponential K, I have no idea, and 10 times, sorry, is 10. Oh, this was the condition 1. And the condition 1, when I set up the condition 1, you obtain, obviously, one exponential equation. And the only unknown in this exponential equation is K. Okay, this is a partial answer. This is not the final answer, of course, right? This is a partial answer. This is a partial answer. So now I try to solve for K. To solve for K is easy. You divide both sides by 500. 611 over 500 is equal to e to the 10k. I put a 10 in the front because it's better. And now it's a crucial moment in which you have exponential equation, but this kind of exponential equation is impossible solve it without logarithm. So you need to apply logarithm. But what kind of logarithm is most convenient? Natural. Why? Because the base is e. When you apply natural both sides, let's see what happened. I know very well que natural logarithm of e to the something is equal to something because this logarithm and this exponential undo each other, right? Because they are inverse function. Therefore, the answer is natural logarithm 611 over 500 equal 10k. Now k alone, que solo hay k, es natural logarithm 611 over 500 divided by 10. And this is the answer. No. Unfortunately, this is one intermediate step, find k value. After that, I need to go to the condition 2. In the condition 2 is the final answer. Okay, the condition 2. Do you follow me so far?
Yes.
So the condition 1 is given in the problem because you need to find the k. K, remember, is the rate of change of the any exponential. And give me of the one specific exponential we are working. Now I copy it one more time our formula, que is this. The condition 2 now, and my formula is population at 30 days among 500. Okay, multiplication e to the kt. Pero who is k? K is natural logarithm of 611 over 500 over 10 and multiplication by 30. Get the time. Okay. So in this equation, I replace k for this expression and t at 30. Get this. This is one possibility to do. Another possibility is you put in the calculator k. You put logarithm 611 divided by 500. Pay attention. Now you are doing the way you prefer. And you get the result of k and you write in the piece of paper. But the disadvantage to write in the piece of paper is that you lost approximation. Okay. Remember, the display of any calculator have a specific amount of digits. However, inside the arithmetic, the calculator, we have more digits. You copy that and substitution, you get good answer, but not exactly answer. Now, one possibility is you using the memory. So you stores k inside the memory of the calculator. Memory 1, memory 2, maybe some calculator have memory A, memory B. And you, after you return, so you put outside the memory to the display and compute that. Either way. But it's not hard. Look, let me show you. You in the display of the calculator, you copy here 500 multiplication after you open the function exponential and inside, okay, you can simplification. Of course, here 10 and 30 is 3, no? So you copy. Inside you copy 3 times natural logarithm parentheses 611 over 500. Close the parenthesis que indicate finish the logarithmic and close the parenthesis que indicate also finish the exponential. And let's see what happens. Let me try my own calculator. 500 times is no 100%, but just in case I like so much specification time. Now, entonces now exponential. Inside the exponential you have 3 times again. logaritmo natural que es ln, entonces ln, 611 divided by 500, close the parenthesis and close another parenthesis, and present it, boom. Wow, I get one answer. Let me know what answer you get. Exactly, Karen. 912.396. You want you copy everything, but now I come back. We are talking about inset and no sense to talk about. No, not always you run off. Now you trunk it because according to the meaning of the problem, we are talking about animal, ¿no? Entonces animal is not decimal. Entonces, exactly. Okay, es 912. 912 inset. 912 inset. Everyone follow me?
Yes.
Yes.
You get the answer? Like me?
Yes.
Okay. Okay. One more problem. One more problem. Okay, next problem talking about problem 6. Okay, look. It's a classical archaeology problem. The archaeology tried to find the age of the different antique objects they found on the ground and go to the laboratory. In the laboratory, they have specific tools to analyze this. So you need to know that in the majority of the chemical element, we have a radioactive isotope. Okay, what is that? It's a carbon-14 test. Carbon is a fundamental chemical element in the nature. And is decomposed in different atoms. Okay, this is isotope. Okay, carbon-14. Okay, so now to determine the age of the different objects that the archaeologists find under the ground, well, they know the physics, know very well the half-life. This is the most important thing you need to understand, half-life. Specifically for carbon-14 is 5,600 years. What means that? Suppose that this is the time, and this is the amount of carbon-14 amount. At the beginning, t equals 0, we have 100% of carbon. But during the time, decreasing, but decreasing exponential, decay. However, the physics discovered that half, 50, for the carbon-14 happen in one direction, that is 5,600 years. So using this information, well, you can determine the age. Specifically, in this problem say, let me read the problem now. Traces and burned wood along the ancient stone tools, were found in certain approximately 1 point. This is the amount, okay, of the carbon-14 is too small. So this is very antique, I suppose. Of the original amount of carbon-14 at the beginning, I suppose 100%. But the condition initial, no initial, is the condition 2. In this case, is the percentage 1 point something, 1.67%. Okay. So now is given if the half-life of the carbon-14 is 5,600 years approximately, when was the tree cut and burned. Okay, so basically I need to find this time, this duration of the time. This time I know, okay, 5,600 years. I need to find this time, the time for the condition. So one more time, we have condition 0, okay, 100%. Condition 1 can help me get the half-life to find inside the family of the exponential what is the rate of change. In this case, decay exponential. And finally, condition 2, in which you have the percentage, but you have not the time. So what is the formula? The formula is similar. Formula is, but in this case, I call amount of substance to any time is equal A null, que is the initial, e to the kt. What is the difference between population, exponential decay and exponential growth? Oh, the problem is that k is negative. That is the reason it decreases. When the k is positive, it's growth. When k is negative, it's decay, decreasing. Now, so now at the beginning, I know k is 100. So amount of substance, condition 0 is 100%. E to the kt. This is for condition 0. For condition 1, I know it's a half-life, 5,600 years. Therefore, half a 50% is equal 100 e to the k times 5,600 years. It's the t. Okay. Now the only unknown is always happening in the condition 1 is k. And so for k, you divide by 100 both sides. Oh, it's all because 1/2 and logical makes sense because I have life. You apply logarithm of both sides because we have exponential equation. Of course, we apply natural. It's the most convenience. Now we have ln 1/2 is equal, this undoes each other, 5,600 k. Therefore, k alone is logarithm of 1/2 divided by 5,600. It makes sense because when you put in the calculator, logarithm of 1/2 is negative number. Remember when they are contradiction, the base of this logarithm is e, and e is approximately 2.71 something. It's bigger than 1. And we compute logarithm of the negative number, entonces logical, without do anything, using my common sense, that this value is negative. So the k is negative. And everything matching perfectly because I know get the k exponential. Okay, now condition 2 gets the last, and that's it. Now this problem, guys, is too complicated because we have 2 stages. Condition 0, condition 1, and condition 2. But it's easy. I need to find in the condition 1, I know that the amount of carbon-14 is 1.67 is equal 100. So we come back to this equation. Okay, exponential k, but who is k? K is, well, k is k, and t. I need to find the time. Okay, let's do it. I don't replace k for this for a moment. I replace in the final answer. Do not complicate it because I need to do some algebra here. Here I, for the moment, left k like a k. Divide by 100 both sides. 1.67, 100. This is e to the kt. Apply one more time. ln both sides. Okay, this is ln 1.67 over 100 is equal KT. Oh, entonces T, que es my goal, my final goal, is logarithm of 1.67 divided by 100 divided by logarithm of 1/2 divided by 5600. If you want, guys, to see more clear, you flip it up and you have 5600 in the top, multiplication logarithm of 1.67 over 100 divided by logarithm 1/2. It's equivalent, right? It's doing. How you put in the calculator like that? You put in the calculator like that. This is the display of the calculator. You put 5600 times ln. Inside the first ln, you put 1.67 divided by 100, close parenthesis, ending the top part, division ln 1 over 2. Something like that. Let me try. This is 5600 times ln what? 1.67 division 100. Close the parenthesis to indicate que finish the first logarithm on the top. Division. Division. Natural logarithm again. 1 over 2. Close the parenthesis. Press enter. Boom. And I get one answer. Let me know what answer you get. I get that. Of course, truncate and years, because we are talking about time and years, no? Entonces, how many years? Very, very antique, these tools, this piece. Exactly. Exactly. Is 33,062 years. Wow, it's very, very antique. I suppose it's before the ejection. Okay. Okay, guys. So fortunately, we finished the word problem. Now we focus on Wednesday and Friday doing the review package. Okay. Okay. Clear?
Okay. Professor, I have a question.
Is there anything due today?
Oh, no. I changed. It's due Friday.
Okay.
When are we
December
getting
9th.
the paper test?
I send you one. I resent again. When I send the video, I resend again the review package and the test. Number 4.
Okay. Thank you.
Okay. But try to find because I sent before.
Okay.
Bye bye. Have a
Have
nice
a
day.
good day.
Have a nice day.